Hello, everyone. Welcome to today's webinar featuring the University of Maryland and Resilinc on the topic of Pouring on the Tiers, Supply Chain Climate Vulnerability Index Findings. I'm Gabrielle, your host and moderator for today. Before getting started with the webinar, let me go over the housekeeping rules on the next slide. Some housekeeping rules. These presentation slides will be sent after the meeting. Please type your questions as they come up in the chat panel located in the right-hand side, and we'll have time for Q&A at the end. We'll respond to any unanswered questions after the webinar. Now I'll hand it over to John Bovett, Senior Director here at Resilinc, to introduce the team.
Hey, thanks. Thanks, Gabby, and thanks everyone for being here today. Really appreciate it. We have an exciting session for you today. I think everyone will get a lot out of it. And I'll do a quick introduction to the team, and special thanks to the University of Maryland at College Park team, and I'll go through them in a second. But I just wanted to say this is the culmination of a lot of work, and really appreciate everyone's effort, and I hope you enjoy the presentation today. First, Sandy Boyson is a research professor in supply chain management at the Supply Chain Management Center at University of Maryland. Melissa Kenney was also heavily involved from ESSIC. She could not be here today, but we have the rest of the panel. Michael Gerst will kick things off, who's an assistant research professor at ESSIC as well, and he'll start off. I'll pass the ball to him in 1 second. We also have Michael Maddox, who was the project manager at ESSIC and helped drive the project as well. And Laharish Guntaka was also heavily involved in doing a lot of the research as well. So again, thanks everybody. And if you have, just reiterating what Gabby had mentioned, if you have any questions as we're going along, use the Q&A panel there, and we'll take as many as we can, or if not, follow up with you afterwards. So Michael Gerst, why don't I pass it to you and we can continue.
Okay, a quick summary of what we're going to talk about in today's webinar. First, we'll start with the objectives of the webinar itself, go into talking a bit about the climate threat for those who are familiar with it, introduce the concepts around the Climate Vulnerability Index, as well as show some results, and then wrap it up with some conclusions and some thoughts on how this is relevant from a risk management framework. So the objectives of this index briefing, first we're going to introduce you to the Supply Chain Climate Vulnerability Index. This is a data-driven model that calculates a risk score that looks at global production locations for the severity of climate threats. Then we're going to move into talking about how this index can be used in supply chain risk assessment, especially for those who are looking to factor in the climate change dimension into their corporate supply chain risk assessments. And finally, we'll conclude with potential actions that could be taken with this index if someone were to use it. Now, to the climate threat, what do we mean by that? So at this point, there's a fairly robust level of evidence that climate change is a real thing that businesses in the public sector should be concerned about. And how we know this is that there are a variety of indicators of a warming world, which are all pointing in the same direction. So this is things such as decrease in sea surface ice, increasing surface temperatures, decreasing snow cover, etc. And what that translates into are economic and societal impacts. And in this case, we're showing ones for climate change in the US. So what this shows is an index that's calculated by the US NOAA, which is a US agency, that collects information on billion-dollar weather and climate disasters. And so what we're seeing already are things such as the wildfires in California, Northeast winter storms, as well as increased hurricane activity. As you can see from this, these are all very localized events. And this is a point I want to drive home, and you'll see as a recurring theme throughout that what this index really focuses on, which is a new capability, is localized analysis of climate threats. And this isn't just something that we're worried about in the present. Obviously, climate change is a very future-oriented threat. And this is, to make this a bit more concrete, this has been looked at from a variety of viewpoints, most recently in the National Climate Assessment in the United States that came out this year. So for example, global warming may wipe off 10% of the American economy, depending on mitigation efforts being successful or not in the near or medium term. All right, and we're going to move into introducing the index, the methods behind it, and some of the results.
Thanks, Mike. This is Sandy Boyson. We had been working with Resilinc for several years on implementing their supply chain risk analytics program with our students. And then we suddenly had the opportunity to begin doing research on some of their data sets. And what was very intriguing to us was the concept of blending the risk assessments and the risk scoring they've done of very decentralized production locations with climate information and adding, if you will, a new risk dimension to the Resilinc portfolio. And so we at the R.H. Smith School of Business and our Supply Chain Management Center teamed with your System Science Interdisciplinary Center here on campus. They're a very large research institution affiliated with NOAA and NASA and the long-term climate assessment centers of both NOAA and NASA, which are also on our campus. And so we've had a lot of good fortune in having them collaborate with us and getting access to their expertise and knowledge to build this index that combines both business vulnerability, business criticality, as well as climate vulnerability and climate criticality. The Climate Vulnerability Index itself is designed to determine, as it says in the box, the severity of climate change at a specific location in supply chain. And it enables us to measure not only the value at risk in each location, which is generally revenue at risk, but also the adaptation capability, the ability of the site, as I'll go into in a second, to withstand great swings in climate. And this is really designed to help decision makers prioritize sites. So as a supply chain decision maker looking across multiple sites in your global supply chain network, it enables you to pinpoint with great specificity the sites where there are extreme vulnerability and a lack of business capability to deal with that vulnerability. So the index is based on two separate threat vectors. One is climate variability. By that we mean both dramatically less and dramatically more rainfall in a specific location, as well as sharp temperature swings. And we look at it over a period of 19 years. And just to give you an idea of just one site and the kind of variability that you can see, we looked at a site near Fresno that back in the beginning of that 19-year period experienced 12 days a year that were greater than 100 degrees in temperature. Now, however, as time has gone on and the climate effect has accelerated, there's 60 days a year over 100 degrees in temperature. So there's been, if you will, a 500% increase over 19 years in the variability of this site. Now, if you look at it from the business vulnerability side, I'm sure that if you know the Resilinc software, if you're a Resilinc customer, you know that they do a lot of different risk dimensions. One is called revenue at risk, and they assign to a geocoded location what the contribution of that location is to corporate revenue. So, for example, if that site went down for any reason and couldn't produce a particular part or a subsystem or assembly, what would that mean to the overall corporate revenue and its impacts? Then what Resilinc will do is they will go in and they will assess a site's preparedness. And they will look at, are there business continuity plans that have been put into place? Are there failover options like alternative production sites that can be quickly mobilized so that there is no loss of revenue, no loss of business production? And the index itself blends production location risk data, as you see in that top third on the right, with large-scale historical databases for temperature and precipitation. And in this case, we have gone back 19 years. Michael Maddox has done a lot of the interrogation of the data sets for that. He'll talk about that as we get a little bit deeper into the presentation. So it blends these things. And the purpose is very basic. The purpose is to enable supply chain executives to look across their entire network and to filter and target locations that represent extreme climate change risks or extreme location risks where business continuity planning levels are inadequate for the challenges that are faced from a climate perspective. And it enables supply chain executives to basically know earlier about which sites, as you see as you will see here on the left, on the dashboard, require no action. They do not have significant climate change risks, to sites where there's a medium level of climate change risks, low revenue at risk. So there's really not that much of a priority for action or investment. And then finally, we have the last dashboard on the right, where we can enable decision makers to understand those sites that have high climate change risks, high revenue at risk, and where there is a great need for urgent action to protect investment and to protect earnings. Now let's talk for a second about our index sample. This is a very large group that we looked at, and we started by looking at over 100,000 locations in the US and China, production locations. And we divided those into basically two types of locations: a sentinel group location, where we have 12,000 locations, where we have all the data for that location, including revenue at risk. We have another 90,000 locations that we call observation locations, which enable us to compare the degree of climate change risk with the preparedness levels of each site. We do not have the risk information in terms of revenue at risk, but we have other information about preparedness levels, operational risk mitigation, disaster planning capabilities, alternative site availability, these kinds of preparedness levels that enable an organization to hedge risk for a specific location. So two types of locations: the sentinel group of 12,000 and another 90,000 observation locations. And you see that over here. This is the location, the locations of all the sites in the US that we looked at. If you go further along, you see all the sites in China that we included, which represented almost 30% of the sample. These are the sentinel sites in the United States, almost 10,000, as you can see, where we have all the information, including revenue at risk. So we know quite a bit about each of these locations from both a climatic as well as from a business importance and business vulnerability perspective. These are the sentinel sites in China. And in order to kind of understand what we did, you need to know a little bit about the sensor network that we used. And I'm going to let Mike Maddox talk about that. And he's going to talk about how we gathered the information for each of these geographic locations.
Thank you, Sandy. So what you're looking at is a map of the Bay Area of California. And the temperature stations, basically the grid points from the satellite, are the pink. The precipitation stations are the green. And so those precipitation stations are 17 miles apart, which is a quarter degree latitude, longitude. And we have a 20-year record for that. And then the temperature is going to be on a half a degree, which is about 35 miles apart. And we have a 40-year record for the temperature in this index. And just to give you an idea of how far apart things are, the middle of the runway at San Francisco International and the distance between that and San Jose International is about a half a degree or 35 miles. And the runways at Newark and JFK, that's going to be your 17 miles or about a quarter degree. So just to give you an idea of the density of the sensor network we've been using. And from this, we determine climate variability. We look at consecutive dry days. So we're looking at over year of consecutive dry days. We're looking at a 5-day maximum rainfall. So that's a moving target every 5 days. What's the maximum rainfall? And we're looking at that on a continuous basis. Then hot days in a year over 100 degrees. So that's 40 years of year to year to year comparisons. And cold days in a year is 0 degrees or less. And we're also using the natural disaster risk from Resilinc. And we're comparing that with our business vulnerability, which is going to be the existence of a business continuity plan, an alternate site, pre-qualification or bring up time. So how long is it going to take if a site goes down? What's the risk? What's the time? We give that a score. And also revenue at risk is given a score to see just how valuable a site is if it does go down. And this is just one site out of the index, but this is the number of dry days. So this is the change in climate variability. So it's 5.6% per year, which doesn't sound like a lot. But if you look at the beginning at 2000, somewhere around 18 consecutive dry days. And then if you look at the end towards 2018, you're up to about 40 consecutive dry days, somewhere in that ballpark. So a doubling of the number of dry days. So it just gives you an indication of water resources locally, if that is important to that site, and we use that as one of our index indicators. And now this is days with temperature above 100 degrees, so this is a 40 years. And if you look at the beginning of the record, we're looking at about 10 days, somewhere in that time frame, and then we're maxing out at 40 over the index, but the trend line is, about 30 days, so doubling twice almost, so almost a 200% gain in number of hot days, and this is just one site that came out of the index. Right here is a map of the climate variability risky sites in the United States, and some of them make sense, and when we looked at this, some of them we had to go double check to make sure they made sense, and they do. And this is a 4-panel, sites with flood risk. So these are sites that are getting wetter or getting more extreme precipitation. And the bottom left is sites with drought risk, so sites that are getting more consecutive dry days. Top right sites where it's getting hotter. And on the right, the bottom right is sites with high cold days. One of the things that popped out in this, and I don't think you can see it in this map because it's cut off, but when we ran the numbers, Sacramento came out as an area with a lot of flood risk, which I'm a hydrologist, and if you would have asked me to put a pin in a map where the riskiest sites are for floods, I would have never picked Sacramento. But after we did a lot of research, we found that there's news reports, there's Corps of Engineer projects, and Sacramento is, in fact, according to the Corps of Engineers, the second riskiest area in the United States for flood after New Orleans. And also with the cold days, what we found was, and this was kind of striking, was Los Angeles is actually an area that's showing more cold days. And once again, we checked popular media, scientific media, and found that, in fact, over the last decade or so, the Los Angeles area is experiencing more cold days, and we were actually having a conversation about that earlier, about, does Los Angeles, do they actually have heat in buildings? Because, in the Northeast, we don't put air conditioning in homes, but, maybe in Los Angeles, they don't think about heat, but the office is experiencing a lot of cold days. It might be something that has to be retrofit. Might be something of interest going forward. And this is sites with high revenue at risk that popped out. And then these are the sites that have high revenue at risk and high climate variability. And as you can see Los Angeles, you can see the Bay Area, you see Denver, Colorado, you see the New York area, but then you see other things, you know, so St. Louis, Oklahoma City, but then you see stuff like Idaho that pop out once you lay this on.
So the next one, this is Sandy Boyson, and I'm going to talk a little bit about some more of the findings. Now, what you see here is the good news. These are the sites that have business continuity planning, they have alternative sites in place, and they can, you know, weather a lot of the extremes that we talked about. On the other hand, we have sites where there's very high climate variability, very high revenue at risk at those locations, and they do not have resiliency. They don't have the continuity planning, they don't have the alternative site location. They have not done that level of work to prepare for and mitigate the climate variability that they're facing. And you can see these are much fewer, but these represent the critical sites that are out there that really require decision makers to take a hard look at them and understand how do you risk-proof these sites, because these are the ones where they have, you know, extreme climate variability. Again, they have very high revenue at risk, and the sites themselves are not risk-proof by any means. So this, unlike the former site in green, where they're resilient and they, you know, are throughout the country, you can see that these are sparser sites, but there's a lot more at risk in them. And that's an important point. So stepping back from the index, results like these, and looking at, well, how is it that we actually, you know, combine these different factors and assign weights to them? Well, we thought about this at length, and obviously decision makers should be able to go in and assign their own weights to specific variables. But for a start point analysis, we determined that climate variability would account for about 40% of the weight. Natural disaster risk would be another 20%. We felt revenue at risk was very important, so we assigned that a 20% weight. And then the rest is existence of a business plan, of a continuity plan, alternative sites, and alternative site bring-up time. So alternative sites are in place, but the bring-up time is, let's say, 52 weeks, which is very long. Then obviously they would be assigned only a certain percentage of the index weight, of the index score. Okay, and you can see that also pretty clearly here. So these are the ways that we built an index and gathered information and assigned them weights within the portfolio of variables. Okay, so if you combine a cumulative index of these factors, in other words, these factors, these variables with the weights assigned, gives us a climate vulnerability index. And the sites that are the most risky sites in the US, the ones that have the highest composite index scores, above 7. And we tried to keep it consistent with the Resilinc scoring system. For those of you who use Resilinc, you know that on a 1 to 10 scale, 1 to 4 is a, you know, kind of low-level risk. 4 to about 5 to 6.7 is considered moderate. But above 6.7 in the Resilinc scoring methodology, that's considered high risk. And you can, and in some cases, the sites that we looked at go up quite high, and you'll see that as we get into the case studies. Can we do it? So Mike is going to talk a little bit about the two cases we looked at. We went into locations, and we basically saw that the index scores were quite high. The climate vulnerability index score was quite high, and so we did further analysis on this specific location.
So this is a site in Portland, Oregon, and when we run the index, it came out with a score over 8, which is very risky in our analysis. In annual rainfall, it's a 9, which makes sense. Consecutive wet days is a 10. You think of Oregon, you think of, you know, the Pacific Northwest, rain, mist, fog. But what really popped out was consecutive dry days. So Oregon is actually, or this site in Portland, Oregon, is experiencing an increase in dry days. And if you look at just the little headline out of the Press Herald, they had less than an inch of rain in May of 2018, and their average is closer to 4 inches of rain, which is fairly significant, especially that time of year. And you can also see where the article below that, where they're talking about Portland drought levels after driest summer, and that also popped out in our index. So this is what we talk about when we, you know, we're seeing sites and then we're going back and checking them with popular press or whatever. And if you look at the bottom number there, the natural disaster risk is actually very low for Portland, Oregon. So this is all climate variability. This is all climate risk that is making this site risky. Also, the revenue at risk is a 9, which is also pretty high in the corporate structure. And another case study was in the Denver area, another index score over 8, and consecutive dry days 10. This is another case of it's getting drier and warmer, and if you look at the revenue at risk there, it's a 10. So this is massive, highly risky site for revenue for whatever organization this is, but the natural disaster risk is a 3. And there is no continuity plan, so the risk is all about the climate and the revenue at risk. So as a manager for risk, this is a site where you want to definitely look at it and see, you know, what can we do, what is going on here, how do we make sure this site doesn't cost our bottom line too much.
So we completed this as a prototype. This took about 4 months to do. We have extensively benchmarked what we've done. We have not really been able to find another index that gets down to this hyper-local level. We've been very fortunate because of the availability of this data through our partnership with the federal government here at the University of Maryland on long-term climate change. So we were able to pull data that we feel gets down to a level of granularity that we have not found an equivalent to in other types of attempts to measure climate risk. So we think that what we've done is sort of unique. And we are learning more about what can be done with this. So one of the benefits that we think is to enhance network resiliency. So network resiliency is all about having the ability to very quickly look at your overall set of locations in your supply chain globally, your hubs and your nodes, and to be able to search for and filter and find those high priority production sites with severe climate change risks, and then to take actions that are effective and that use your scarce resources in a very critical and strategic way. So enhancing overall network resiliency by having this kind of visibility into the risks from the climate that each of your sites is facing, as well as each of the sites' capability to respond to that risk, is, we think, a rather important new addition to the toolkit that supply chain managers are going to need, particularly as we move deeper and deeper into hyper-accelerated climate change, which I'm sure you understand is the prediction. The other thing that it can do is facilitate production switching, and I unfortunately speak about this on a personal level because we saw a lot of this in Puerto Rico. My wife is from Puerto Rico, my family, I'm not Puerto Rican, but the family is there. I spent a lot of time in Puerto Rico, and we saw a tremendous amount of production switching after Hurricane Maria, where the critical, drug production, I'm sure you probably know that Puerto Rico is a major center for pharmaceutical production. It actually accounts for about 50%, is the last I heard, of the profits of U.S. pharmas. And they were able to make a very quick, proactive posture towards location shifting, a big part of their response to Maria. And some of that, of course, had to do with their ability to switch to a less risky location. Of course, that's the whole goal here. So by knowing which is the less risky location from a climate perspective, and knowing which location is better able to cope with that risk, it can facilitate production switching very quickly during times of duress, as we saw in Puerto Rico after Hurricane Maria. The other advantage that the index we think can provide is gain insights on hyper-localized advantages. Small changes in operations can account for significant ability to respond to risk. We did a study on Procter & Gamble. They manufactured 50% of the coffee supply out of New Orleans. And they were the first manufacturer to restore operations after Hurricane Katrina. And they had used satellite imagery to very, very carefully select one of the few elevated industrial lots in New Orleans. And just that heightened elevation enabled them to kind of get online much quicker than other manufacturers in their geography. So, if you know that you're at hyper risk in a given area from climate change, let's say from flooding, it gives you the ability to kind of, as P&G did, even in a bad situation, find that sort of island in the stream, take advantage of it, and hopefully, help you weather the catastrophe a little bit better than your competitors. It also enables you to scope out climate change-related cost factors. Okay? What is it going to cost for you to input into that location? What's it going to do to your return on investment? How is it going to affect your corporate revenue strategy? You'll have, I think, a better grip of where you need to spend money and how much that might actually be. And then finally, to develop strategies to better risk-proof locations. Now, this is a work in progress, okay? We do not think that best practices have been fully captured in this area. We hear about best practices from selective industries. So, for example, flow-through building designs on the first floor so that flood waters can basically run through a building without harming upper floors, or placement of generators on roofs, as they did, for example, in New York during Hurricane Sandy. That was a big lesson learned from that. So these are the kinds of benefits that we think can be generated by using the type of index that we've developed and gaining this highly localized visibility into climate change. Now, let me go back for a second to the use case examples. We thought a lot about what kind of companies might benefit from this, what kind of industries might kind of benefit from this. IT companies, I mean, if you look at, for example, what happened in Oregon, which Mike Maddox just talked about, and the drought affecting Oregon. Well, I'm sure you know that many chip makers, semiconductor manufacturers moved up to take advantage of the hydroelectric power in the Columbia River. So what is that going to do to their data centers up there if there's a tremendous reduction in the flow of water through the Columbia River basin? So it would obviously affect their ability to protect their network data centers. So IT companies can certainly benefit from this kind of information. Pharma companies are another set of players we think could benefit. We're particularly concerned about water purity and feedstocks in production and the ability to ensure uninterrupted supplies. I'm sure looking at the results of the Hurricane Maria, we've had a tremendous amount of disruption in critical supplies of things like saline bags, bags that they use in hospitals to put IV systems into folks. When Puerto Rico went down, that whole capability went down with them. It created tremendous crisis, if you will, in the health system. So pharma companies kind of need to know where vulnerabilities are. Obviously, the DoD has been concerned, but is increasingly becoming more concerned about the effects of radical climate change on their forward positions around the world, and this is a huge issue. Finally, regional and local planners who are worried about their transportation networks and which are the nodes in their networks that are vulnerable, or their business clusters. Are there business clusters in specific areas that are subject to even more radical climate change than other areas, and they need to kind of plan for that and build that into the equation. And finally, what we just wanted to put out from our learning on this about the index is that there's a mindset change that the index can help support. And having taught supply chain risk for a number of years, there's a great difference between how planners now deal with disasters and how same planners are going to have to repurpose their systems, their perspectives to deal with climate change management. So if you look on the left, obviously disaster management is episodic. It's very time-limited events. This is very different than what we've described to you about the long-term, ongoing, continuous fluctuations that are going on in climate change that businesses are going to need to kind of calibrate to and respond to. Also, extreme events, precipitation, temperature, can result in very sudden and very large-scale disruptive threats to operations. So, adapting to this constant environment of volatility is, I think, a lot different than looking at these sort of, episodic, this time between events to prepare. In the case of climate change, it's constant and ongoing. And in the traditional disaster management, just to focus on one thing, you can repair and patch an affected infrastructure. Where in change management for climate change, you almost have to kind of rethink your entire set of priority sites. You're going to have to reevaluate how those sites are going to access water, energy, and communications in the face of the kind of disruptive effects of climate change. And also, I think it puts a real value on developing long-term alliances with emergency responders and fire departments and other authorities, because without that, you won't be able to have that constant adaptive capability in place that goes well beyond the borders of your own firm. So it's a public-private partnership that I think needs to get set up to respond to these long-term climate issues. So I think we're going to now move to our conclusion section. Mike is going to sort of wrap up our last comments, and then I guess we'll have some time for Q&A.
Okay, yeah. So we've shown a lot of initial results from this project, and we'd like to summarize the broader points that come out of this before we move on. So one of the high-level results that came out of this is that global supply chains are all going to be affected by climate change, but at a very differential rate. So this, if there's one thing that we can really drive home, is that it's going to be highly differential depending on location. And our index has shown that these highly localized effects can be captured. So for example, the multi-year cold streak that was mentioned in LA, or flooding trends in Sacramento, just as two examples. You can imagine that there are many more. Because climate change is going to shift the sort of distribution of past problems that risk managers are used to thinking about, with which strategies are developed for, this leads to the point that past strategies may not be effective because the risk distribution is changing. And then finally, this points that there is a need for rapid experimentation and scaling of courses of action that are proven to work through mitigating climate change impacts on the supply chain. And of course, as the previous point that I mentioned, these are very much calibrated to a world that might not exist in the next, 5, maybe 10, at least, definitely after that. And we want to point out that we think the Resilinc community is well positioned to share and compile these COAs and mine and gain insights from them. And then finally, I would like to point out that more immediately, if you are Resilinc customer with production locations in the US or China, that you could use this index to find out how your site measures up to the increasing threat of climate change. Okay, and we're going to stop there, and thank you for your attention, and we'll take questions now.
Yeah, thanks. This is John. Thanks again to the team. This is fascinating for a number of reasons, and Sandy and I, we go back many years in having some of these discussions around how can we leverage and combine these types of unique situations. So combining, Resilinc data, from an operational and sourcing perspective with this kind of advanced data set and knowledge of climate, and what would happen if you combine these two? And this is the result. This is pretty fascinating. If I look and I looked at some of the questions and also the attendees, I'll pose a couple of questions that I kind of took from a few folks, and I think it's one of what advice would we give? If I look at the folks in the audience, it kind of falls into a few categories. Many of our supply chain or sourcing or procurement people at different companies, and I guess for the group here, what advice would we give them? Is this information that they should take immediate action on? Is it more should they take a more long-term view where their supply chain is? What's sort of some of the practical advice coming out of this now that we can look at it as a whole? How would we wrap this up? What should they do in the short, medium, and long term?
Well, let's start with the basics, okay? And the basics are that the climate is changing well at a pace and with a variability that I think none of us imagined maybe 20, 30 years ago. And so it's very important that just the simple act of prioritizing the locations based on climate exposure, exposure to accelerated climate change, I think that alone will give supply chain managers an understanding. And if you combine it with the typical Resilinc risk dimensions that we brought into the index, I think you get a pretty good understanding, first cut understanding of where you have to focus scarce resources. Now, having been a practitioner before I came to academia, there is very limited money in many organizations and many corporations to go into mitigation activities. So the point is, now that climate is emerging, and it just emerged according to the insurance survey of risk managers, Emerging Risk Survey of Risk Managers, 12th annual survey, showed that 1 in 5 actuaries view climate change as the top emerging risk in 2019. So that's a pretty good group that is now believing that this has moved into the short term. This is not some long-term problem. It is a long-term problem, but it's continuous into the long term, starting now. And as you've seen, when you have locations that you getting a lot of supplies out of, and a lot of money is coming out of that location, and it's having 500-fold increase in days above 100 degrees. It's you have to factor that in. It's very basic. So I think in the first instance, these kind of tools are very practical just in deciding where you have to put your limited attention and resources. No, there's not a working supply chain manager who doesn't live under these kind of constraints. And so it helps you deal with those constraints and target and allocate resources much more efficiently than if you did not have this information. So I think that's the start. Do you want to add something else, Mike? I can tell you that, we've been doing a lot of research on this, and I've been studying climate change issues since about the 1980s, and when it wasn't even, something that was so popular or so much in the media. And it's not going away, and it's accelerating to the point where it's becoming visible to everybody. And I think that's really the issue here. So this is a basic tool, but it gives you something you couldn't do before, potentially.
Yeah, thanks, Sandy. Another, I guess, a couple people have asked. So, how can we get our hands on the data? So let me touch on a little bit on that. So, for I guess that kind of people fall into a couple different categories. For existing Resilinc clients, please, and I'll wrap up with my contact information. I can send if anybody's interested. This is John Bovett at Resilinc, and we'll send out a follow-up email with the slides and everything. But we're working with the team now. We kind of basically we've done the research, not we, but the team that presented today, and we're working on kind of assessing how best to roll it out for existing Resilinc clients. For new clients that are interested, obviously the data would be available, inside the Resilinc environment. We can touch on that. We're working on now with our combined teams on how best to make that available. So that's sort of where we are. We came out of the research phase. We're presenting some of our findings, and then we're productization comes as the last step. So. Let me see. I think, and Sandy, one of there's a set of folks, a number of other universities, university professors, and I think some students as well. What kind of mapping it to their domain and what they may be doing. How would you advise on some of these, findings for them?
John, can you be a little more specific about maybe the disciplines? Do you have any sense of the disciplines these folks?
I don't. I can just see that they're coming from universities. I saw titles of professors. I saw some, and I saw some students. So I just thought we'd. But I guess the question is it? I guess if there's any specific interest, we could let us know, and we can share. Put people in contact if they're interested in additional information.
Yeah, I would also suggest that, and depending on on their campus, the size of their campus. I mean, we're very lucky here at Maryland. My understanding is there's 7 major climate change institutes in universities across the country, is what I heard. But there's a number of universities that have secondary resources in this area. So I mean, they need to I think they need to look in their own campus and see what kind of resources they may have that can bring in the climate change factor to their local and regional production systems. I think it's really important to partner. I mean, we're a business school. We could not do this on our own. I mean, we obviously know about business risk, but we have experts here like the two Michaels, who, we could not do this unless we had access to these enormous data sets. How big do you think these data sets are?
So the temperature data set is, or the precipitation, sorry, and this is just for one day, is close to 700,000 grid points. So 1 day times 365 days times 20 years, you get an idea of how much data that is. And the temperature is a little different. It's close to 500,000 grid points for each day because there's a minimum and maximum times 40 years. So it gets big in handling the data and then handling the Resilinc data. It's a problem.
Yeah, we had to develop a lot of internal information technology architectures, database architectures, and virtualization of security. I mean, everything that we do is on a highly encrypted virtual server. None of the processing has been done on local machines. It's all been done on our AWS-based highly secure server. So I would encourage you, if you're going to be combining very sensitive business risk information, to be sensitive to the privacy issues and the security issues. John, that we've done a lot of work with the National Institute of Standards on cybersecurity.
Right.
And we're very sensitive to that issue. And we've dealt with some very, very sensitive information about cyber systems in big companies and organizations. So we started with that attitude in mind, and so everything has been virtualized and all work has been done behind a highly secure firewall.
Yeah, and I would thanks. And what I would wrap up with is this group, or at least a few of the members, will actually be, there'll be an on-site presentation of this material and discussion, so you can meet the team on June 11th in Thousand Oaks, California. It's being hosted actually hosted by Amgen, our Resilinc client. And if anyone is interested in that, we'll also send out the link. We have it's actually pretty full, but we can probably squeeze in a few more people if anyone's interested that's attending this session today and would like to get more details or like I said, meet the team and hear some other presentations. So that's going on June 11th in Thousand Oaks, California. So with that, again, I will thank the Maryland and ESSIC team, and Gabby, I think I'll turn it back over to you to wrap us up.
Great, thank you, everyone. So I don't see any other questions coming in. So we can end this session now, and we will follow up. And if you have any other questions, you can direct them to John. And his email will be found in a follow-up email, but his email for now is john.bovich@reslink.com. That is spelled jon.bovit@resilink.com. Thank you, everyone. Have a great day.
Thank you.